the mu of the liquid will vary 5 by 2 minus T by 4 until it reaches a steady state value of 5 by 4. What is the method? I think if you have to go back to the original. So this is the, I'll bring a better diagram. Okay, this everything is a liquid. This axis. Yeah, we'll take it. So this is the slit. Here we have a slab. I think it has become. Now you get into the problem, and we have a screen here. Let's get into the discussion now. So this is the slit S1. It is illuminated by monochromatic light of wavelength lambda. Now this is the mu of slab. This is a mu L liquid. So what is the method? I think the method what we used to do is like, and there's a path difference between the rays. So you do one thing, write that equation. So don't go for directly writing that path difference equation. Very dangerous. I think I insisted to write the equation. So path difference. So what do we write? Delta x is equal to S2p dash minus S1p dash. So what is S2p dash? S2p. Where is this? This everything is there in the liquid, no? So mu times of that will come first. Mu times of mu L S2p. In the path of that there is a slab minus T plus mu of glass minus this will be mu L S1p. Oh, can you remember? You are not supposed to write the Dirichlet equation. This was the method the book suggested, so I had to insist on that method only. This is applicable in all the situation. Water be that here liquid, here slab, here some slab if you brought, some medium you brought here one slab is there. Just writing this equation. The net path difference they should be equal to. This is equivalent to in air. Huh? Okay, we have only this much of the equation. After this, what you are going to do? Okay, this one delta x equal to mu L S2p minus S1p. This is the one equation. Oh, this is. I think okay, no? Mu L S2p plus this one. Then mu G minus mu L into T. So overall, this is the equation for the path difference of the rays arriving there. S2p minus T is what in the liquid. Then remaining some T length, it will move in a slab. That is mu Gt. Minus, again this will be S1p is in the liquid. Optical path length of that should be mu L S1p. Now look at, let's get into, okay, after writing this equation, let's come to the picture. It's asking now, find the time when the central maxima is at point O. What is the basic necessary condition for the central maxima to be at point O? S2P minus, okay, for center, okay, I'll do one thing, one more equation. So this, shall we go for writing like this? What is y? This is a y. Mu g minus mu l into t. Keep till here. Okay, this is the equation for this one. If you want to keep it here now, delta x equal to n lambda. Keep like this also. One more. So this will be mu l dy by capital D plus mu g minus mu l into t. Let's get into the discussion. What do you mean by central maxima should be at O? At O means I think you are going to define y equal to 0. And strict condition is telling condition is telling like it should be central maxima should be at the axis. So for central maxima, what is the requirement of n? N should be 0 and it should be at O. At the axis means y should be 0. Substitute this. Now you have that liquid. What time is asking? Substitute that and calculate the time. T is the thickness here, not, don't get confused here. Two seconds, huh? Yeah. So I'll put it here for at axis. Y should be 0, n should be 0. So therefore 0 equal to 0 plus mu g minus mu l into t. What is that mu l? 5 by 2. Thickness of the slab, if you want, we'll make it Tg. Again, we may get confused with the instantaneous time it is. Okay, calculate the time. 2 seconds, huh? Check once, answer. 2468. Anybody? I think 4 seconds. Check once. What is the speed of central maxima? What is the speed of central maxima when it is at O? When it is at O means is asking speed. So I think you put n equals 0. Differentiate this equation. N must be 0. So 0 into lambda mu l d derivative of this. I should write one equation. Wait. Right. Then I'll differentiate. N lambda equal to mu l is given 5 by 2 minus t by 4 into tj. Let's differentiate. This is 0. This will be minus of this will become mu l is this much, no? So Tg by 4 dt, no? The dt is what went. So this will be expression for dy by dt. Wait. Some calculations mistake again. The mu L is also here, no? One more is there. I didn't check that mu L. We'll do one thing. Mu G minus mu L Tg. Okay, this will become y is equal to capital D small d mu G minus mu L, or this will be mu G by mu L minus 1 into Tg. Capital D by small d. N equal to 0, then we are writing this equation minus of, so this will become 1 minus mu G by mu L into, now we'll substitute the mu L value, then you differentiate. Mu it will be 5 by 2 minus T by 4. Now you differentiate dy by dt. This will become plus d mu G Tg by small d. We'll keep all these things, minus 1 by 4 is asking what is the speed of center when it is at O. So put t equal to 4 seconds, you'll get the velocity of center, like a central maxima. Okay, the symbols little bit. Tg something, thickness of glass slab, no, it is. The mu of a liquid varying with the time is some sort of like should not be there, only because what we do is like we are going to heat up the liquid. As you boil the liquid, the temperature of the liquid will change. Due to variation in temperature, there will be variation in the refractive index. This is actually the methodology. With the time it is varying means with the time I'll be supplying it. Otherwise, the mu is some sort of like a inherent parameter. It should not vary with the time. So how do we vary with the time? Means we supply heat. Due to as I supply heat with the time, because the heat supplied, the heat absorbed by the body also depends on time. So therefore, the density of substance will change. Due to variation of density, the mu will change. This is actually the methodology. On the background, one has to think in this way. On its own, the mu cannot change. Under the influence of heat only, the mu can vary with the time. This is the thing. So they may test you with this basic idea also. I do have options, so check once. This will be writing this equation. I feel like very essential. Student has to really put the path equation. The whole Ydse, it all depends upon just writing this path equation. I think we have discussed enough number of problems, different varieties of situations I shown where how to write this path equation. Rest all mathematics. The only thing is which when you are doing revision after reading question, just think only on this part. After this, all the mathematics, no, you can see. So like that, I think 1 hour, some 20 problems easily you can revise Ydse. Only don't focus on this mathematics. These are the mathematical conditions. If you know this, the rest of everything is fine. Read the question. Little bit I'll be testing your mathematical skills. A monochromatic light source